Значит, okay, let's continue with the SARIMA model. If you have any questions about home assignment, then it's the right moment to ask them. 1, 2, 3, 4, 5. Вышел зайчик. Yeah.
По time series тоже можно, да?
We have time series now. Econometrics is Monday, next Monday.
Actually, I would like to know about gradations.
We have discussed that we have exercises on a data camp. We have a written exam. So, as far as I remember, what was it was noted somewhere in or 50-50, but it's in chat. I can check. Either 46. I don't remember. Either 46, but it's in the chat.
Ну, то есть дата кэмп, если сдать, то минималочка пройдена.
Yeah.
Хорошая новость.
Можно на 0, да?
Yeah. Yeah. But you will receive a low grade. You will pass if you do data camp, but you don't do exam, then you will pass, but you will receive low grade, like
Low grade. Он есть.
Yeah.
А почему дата кэмп дедлайн после экзамена?
You may do it before.
Согласен, несгораемый балл есть?
Yeah.
Ты его сдал.
Yeah. Because honestly, because I think that it's better. I understand that formal rules of HSC asks me to grade the data camp before exam, but I understand well that it's better to break the rules and to give you one free day after exam, because if you try to do data camp before exams, one thing will happen. Either you will copy-click solutions, yeah, that's the first possible thing. Either you will be less prepared for exam. And if the deadline is after exam, then you can prepare for exam. And after exam, you can, yeah, I have a whole day dedicated for data camp, and I will know time series better. Because my interest is not in your grade, but I hope that some of you will use forecasting time series methods we discussed. And so that's not. You have an option to pass. And if you'd like to pass, do data camp, copy, click. That's okay.
But in any way, it's better to be sure that you pass the exam anyway.
Sorry?
It's better to be sure that you will pass the exam anyway.
Yeah, yeah.
It's better only just to be sure.
But if you just do, but you can see on data camp your progress. So just you see your own progress. If you see that you have completed the course, then be sure I will see too. So just don't worry. If you see course completed, fine.
May I ask this question again? So the quality of the progress doesn't...
Yeah. Experience points do not matter. The only thing that matters is complete. The course is completed. All the chapter is completed. If you have completed the course partly, so you will receive part of the grade. Okay. So if you have completed, I don't know, if the course have 5 chapters, you have completed 4 chapters, and have 4 out of 5, of course. So yeah, you can take any number of hints you wish. So if you, because I think the honest training is done like this. You Google solution, you try it yourself, but because in programming it's like this. Sometimes I'm not exception. Sometimes I struggle with programming, something it doesn't work, then I Google, I go to Stack Exchange. That's okay, that's normal. Okay, let's...
Excuse me.
Yeah.
Can I also ask about assignment and all stuff?
Yeah.
So the terms for econometrics and time series are basically kind of the same, yes? In terms of
Yeah.
percentage rate and the structure of the final mark.
We need to look in the agreement because it was sent by email and I don't remember, was it 4060 or...
Yes, and the second question is about some kind of mock exam, maybe will you provide us with one?
You have passed exam.
Huh?
On the web page of the course you have passed exam.
Excuse me, on the web page of the course, there
You
is
have
a mock
passed
exam.
exam. Yeah.
The HSE website, yes?
Okay, I will send one small chat of the mail.
Thank you.
But you have passed exams at least for 1 or 2 years. I think 2 years.
In regards to the home assignment, could you please walk me through the second exercise? Most of it was done by me. The only obstacle was sub-point number 2.
Okay, correlations. Okay, so exercise number 2. We have YT, it's auto-regression of first order. YT is 9 plus 0.5 YT minus 1 plus UT. And we have additional information that random variables UT are independent normal 0, 16. That Y1, Y2, Y3, YT is independent of future shocks of UT plus 1, UT plus 2, and so on. So past observed value are independent of future shocks. And it is also, so first equation, second that shocks are independent, third that past observed values are independent of future shocks, and the next assumption that YT is weakly stationary. Weakly stationary. So we have equation, some information about U1, U2, some information about the link between old Y and new shocks, information about Y that is weakly stationary, and the question is to calculate rho K. Okay, so let's discuss what it is. Well, yes, it's a good question that I think the level of difficulty is roughly of exam, so it may be one exercise in the exam or something like this, calculate autocorrelation function for some process. That's a good, that's a simple exercise. Okay, so first, what is rho K? Yeah, rho K is autocorrelation function. Autocorrelation function, and it's basically correlation, if it's autocorrelation, between
Previous and
YT and YT minus K. Okay? So K is a time difference between observations. So we need to find this correlation. Okay, so to find correlation, what we need to do? Obviously, we need to find covariance of YT and YT minus K, and divided by what? By square root of variance of YT times variance of YT minus K. That's the definition of correlation. Okay, finally, let's use some information, and we will simplify correlation. Okay, what does it mean? YT is weakly stationary. What does it mean? YT is weakly stationary. This assumption number 4 says something about variances, about expected values.
it's all about being constant. No?
Roughly, yes. What is constant exactly? You are right, but what exactly is constant?
Expected value.
Yeah. Expected value of YT is constant, so it does not depend on time.
Yes.
What else?
The variance is constant.
Yeah, the variance of YT is, let's denote it by gamma 0 constant. What else is constant?
Covariance.
More exactly. You're almost right.
Covariance depends on age, the difference
Yes.
between the current
Yes.
observation
Yeah.
and the previous. The
The
delta.
variance of YT and YS depends, so this is Y, this is gamma. Is it okay? Letters are different. The difference is, can be seen, yeah, from my
I suppose it's what's right that the
Yeah.
difference between S and T is constant. In general, it's written like T and T plus H.
okay, I may write, yeah, you are right that you may write it like covariance of YT and YT minus K depends only on this time difference.
On
Of
K.
time difference on K. Or, as I have written, that's also true, that's fine, and that's fine. Both equations are equivalent. either you say that if you have y number t and y number t minus k, this covariance depends only on the number of days between these two observations. That's the same. If you have observation at day t, observation at day s, the covariance can depend only not on t, not on s, but only on t minus s. Okay? So basically we know. So for example, let's illustrate the third property. Covariance of y7 and y9, according to this property, should be equal to covariance between y100 and y102, because there are 2 days there and 2 days here. Okay, but it may not be equal to covariance of y7 and y12, because there are 5 days there. Okay, so this requirement is a little bit subtle. So covariance is not constant, but it may depend only on number of days between two observations. Okay? Now, we see immediately that these two variances should be equal, because that's the definition of stationary process. These two variances are equal, so variance squared square root cancels out. I have covariance of yt minus k, divided simply by variance of yt, because these two terms that are multiplied are equal. It's something like square root of a squared. Square root of a squared is a if a is non-negative. Okay? So we need to calculate variance of yt and covariance of yt minus k. Let's start. Let's calculate. So we have used force assumption to simplify the expression for covariance. Okay, let's find variance of yt. Variance of yt is variance. I will find denominator first. Variance of 9 plus 0.5 yt minus 1 plus ut. Okay, variance of 9 is 0. So I have 0.5 squared variance of yt minus 1 plus variance of ut, but I can use the assumption number 3, which says that past observed values and future shocks are independent. Here I have ut, current moment, and yt minus 1. This is past y for future u. Okay? And according to assumption number 3, they are independent. Okay? Assumption says nothing about y7 and u6. They may depend. They may be dependent, but u6 and y5 are independent. Yeah, okay? If y is before u, then they are independent. That's the meaning of the third assumption. Current observed value, and these are future shocks. Okay, so plus 0. Two covariances, I don't add two covariances. So I have a very simple equation here. Variance of yt equals to 0.25. Variance is constant according to the properties of stationary process. So I may replace it by variance yt plus 16. Okay, I immediately solve for variance yt. Variance yt is 16 over 1 minus 0.25. I have calculated denominator. Now let's go for numerator. Let's calculate covariance. Okay? We have calculated denominator. Now we pass to the numerator of this ratio. Okay? Any questions? Up to now? Who is with me?
y16 why we need divided by 1 minus 0.25.
Just move this term to the left hand side,
Okay.
and the right hand side is 16, and we divide. Okay, let's move on to the covariance. First, let's calculate rho 1. Rho 1 is covariance of yt minus 1 divided by variance of yt. What is covariance of yt minus 1? I will replace the first yt, the left term in the covariance, I will replace by the formula. I will plug in the left yt. I plug in. So it will be covariance. I will forget about 9 because 9 doesn't influence variance, neither covariance. So I will just ignore this 9 because 9 doesn't influence covariance. So I will just write 0.5 yt minus 1 plus ut with yt minus 1. Once again, I should, covariance is linear, so I should take covariance between first term and yt minus 1 and ut and yt minus 1. So first is 0.5 covariance of yt minus 1, yt minus 1 plus covariance of ut yt minus 1. Now once again I use all the properties given in the text. Because the process is stationary, this is equal to what? No. Covariance of a random variable with itself is called variance.
It will be 16. Yes.
Variance of yt minus 1, because covariance of a random variable with itself is variance. Plus, and this term is 0. Why?
Because the term
Yeah, because we have a third assumption that says that past observed value and future shocks are independent. Okay? This is past observed value, y is observed, and u is the future shock. So they are independent by the assumption number 3. Okay. And variance is constant because the process is weakly stationary. So it's just variance of yt. So we finally have calculated that it's 0.5 variance of yt. Or I may plug in because we have already found variance. So I may find explicit value 0.5 times 16 over 1 minus 0. Okay, I have found covariance this is gamma 1 covariance between two observations that are 1 day apart, and this is so I can calculate rho 1. It's 0.5 times variance of yt divided by variance of yt, and bingo, that's 0.5. Yeah? Okay, now let's calculate rho 2. We have plenty of time before exam. We can calculate rho 1, rho 2, rho 3, rho 4, rho 5, rho 6, rho 7, and so on. Okay, let's calculate rho 2. How do I calculate rho 2? Rho 2 by the same formula is covariance of yt minus 2 divided by variance of yt. How to calculate covariance of yt minus 2? Once again, I will plug in yt. I use the same logic, the same algorithm. The same logic, the same algorithm.
It will be 0.
It will be covariance of 0.5 yt minus 1 plus ut. Once again, I just ignore 9 because 9 is a constant, does not influence covariance, doesn't influence variance, influences only expected values, but I'm not calculating expected value. Okay, covariance with between yt minus 2. Okay, that will be 0.5 covariance of yt minus 1, yt minus 2, plus covariance of ut, yt minus 2. Once again, the second term is equal to 0 because future noise, future shocks, future random noise with past observed values. We may have inverse. So, for example, this assumption says that covariance of y6 and u8 is 0, but covariance of y8 and u6 may not be 0. So, when u is before y, then they may be correlated. But if y is before u, then they are uncorrelated. Okay, so it's 0.5. And we know between these two, or between t minus 1 and t minus 2, how many days are there? Between t minus 1 and t minus 2. There is only 1 day, okay? So, according to our fourth assumption, I use it extensively, all assumptions, they're all needed. This is covariance between yt and yt minus 1. Because covariance is according to Whitley stationary assumption, covariances depend on the number of days between these two observations. There is 1 day there, 1 day here, so covariances are the same. But this covariance, we have already calculated it. Here it is. It's 0.5 times 0.5 times variance of yt. Finally, I plug in there. 0.5 times 0.5 times variance of yt divided by variance of yt. And finally, I get second correlation. That is 0.5 squared. That is the answer for row number 2. Okay? Shall we calculate row number 3 or the pattern is clear? The pattern is clear or we need to do one more row? Okay? It's clear. You just calculate row 3, the denominator will be the same, and so on. Okay? And this correlation, they are more or less interpretable. Why I like to use them? What's the meaning of this correlation? What is the meaning of row 2? Why? Okay, we have calculated what is the meaning of this object. It roughly says, what is the meaning? It's equal to 0.25, but what does it mean?
This population is decreasing. It's geometric progression.
Yeah, I agree, but I would like something more.
That the current observation is less dependent from previous observation. And the further is this previous observation, the less is the correlation between.
Yeah, I agree. But my question is how to interpret this value, 0.25. What does it mean? How to interpret exactly the value? The correlation 0.25. What does it mean?
That it's 0.25.
25% of times.
It's closer to 0 than the relation is.
I understand that 0.25 is close to 0. I would like to add the following very easy and correct interpretation. Because in this case, we may just say that if yt minus 2 goes up by 1, so we know that there is average level of yt minus 2. Yeah, we have expected value of yt minus 2. We can calculate average expected value of yt. That's not a problem because the process is stationary. We can calculate expected value. But if I compare two time pass and and yt minus 2 was higher than expected value by 1, then yt goes up by 0.25 squared. That's a direct, easy interpretation. That means how yt reacts to the increase in yt minus 2. That interpretation is possible for stationary process, therefore, for stationary process we have such an interpretation. For stationary process we have a very easy interpretation of correlation. That's a factor how past values influence current value. Okay? Yeah? So now let's move on. Let's introduce more complex auto. Yeah, that's all. I have asked your question.
Yes.
So now let's introduce more complex auto-regressive process with seasonality. So how seasonality enters in auto-regressive processes. Last week we have discussed some special notation that we can write the same equations using lag operator. Do you remember? Lag times yt is equal to... I remember we have done this. But it's very easy.
Yt minus 1?
Because it's log.
Yeah.
It's in power 1.
Yt minus 1. Okay, so we have a language how to write equations for yt without using yt minus 1. So we can write something instead of yt equals to 9 plus 0.5 yt minus 1 plus ut. We can write something like yt 1 minus 0.5 L times yt equals to 9 plus ut. Okay, we may write the same thing like this. Is it clear that that's the same equation but written differently? So if you just open the brackets, you will have yt minus 0.5 yt minus 1, and you immediately recognize the same equation. Okay? So that's the same equation, but written with this strange L lag operator. That's just a notation. No deep sense, just a notation. No, that's not very difficult, just a notation. Okay, this notation allows me to write every SARIMA process. I can write something like lag polynomial of lag times yt minus mu equals to some polynomial of lag times ut. So every process SARIMA can be written in this form. Let's decipher some examples. I will write some examples and we will decipher them into actual equations. So to make, so first exercise, so very easy exercise. The goal is to write equation without lag, difference, or seasonal difference. Write equation without lag, difference, or seasonal difference. Something like 1 minus 0.7 L times delta yt equals to 1 plus 0.4 L times delta 12 ut. So let's practice a bit, decipher some equations written in terms of lag. So I have some polynomial of lag. So I recall that delta is just 1 minus L. It's difference between current value and previous value. Delta 12 is seasonal difference. It's difference between current value and the corresponding level of the previous month. Okay? That's easy.
Yes.
Okay, let's. So I'm speaking about monthly data, but if you speak about quarterly data, you just replace 12 by 4, and that's all you need. So I will speak not about abstract frequency m. I will tell about monthly data. Frequency is equal to 12 months by year. Okay, let's write the same equation without L, difference and seasonal difference. Lag, delta, delta 12. Okay, what is delta Y? It's YT minus
YT minus 1.
YT minus 1. So it's 1 minus 0.7L, and I write with lags. First I will write with lags, and then I will remove lags completely. It's 1 minus L to the power 12 times UT. Okay, let's multiply. 1 by 1 is 1. L by L is L squared. I have minus 0.7L minus L minus 1.7L multiplied by YT equals to, let's multiply 1, it's minus 0.4L power.
L в квадрате.
Sorry?
Второе слагаемое, там не плюс ли?
Плюс 0,7. Потому что мы минус умножаем плюс 0,7 умножаем на
1
минус L.
плюс 0,7 L в квадрате.
Yeah, okay. Okay, minus 0.4L13 plus 0.4L minus L to the power 12 times UT. Okay, I have multiplied lag polynomials. Now I open the brackets. 1 times YT is YT minus 1.7 YT minus 1 plus 0.7 YT minus 2 equals, and some amount of shocks of future random noise. So I have UT, I have minus 0.4 UT minus 13 plus 0.4 UT minus 1 and minus UT minus 12. That is the corresponding equation in terms of, so this is written with lag difference and seasonal difference. This is the same equation written with without lag, without difference, and without seasonal difference. And it's typical equation for ARIMA model. ARIMA model is always like this. In ARIMA model, you always have some polynomial multiplied by y, probably y minus mu, equals some polynomial of lag multiplied by random noise. So that's a general structure of ARIMA model, okay? Yeah? The problem with ARIMA model is that this equation is non-interpretable. We cannot say, what does this 0.7 mean? I don't know. That's just a form to write your result. Correlations are more or less interpretable. So if you try to correlate to calculate correlations, then they are more or less interpretable because roughly, if you have calculated, let's say rho 2, that is 0.25, you can interpret it. But the equation itself is almost non-interpretable. So let's discuss some. Let's write some more models and. So okay, let me introduce one more intermediate model, and then I will introduce ARIMA model in full generality. Okay? Yeah. So first I will introduce another simple model, another example of easy case, and then we will go back. We will not go back. We will describe the general case. Okay. One more example. Let's consider the following: a seasonal autoregressive model of order 1 or 1 with frequency 12. So it's seasonal AR model of order 1, 1 and frequency 12. It looks like this. 1 multiplied by 0.7 times L multiplied by 1 plus minus 0.5 L to the power 12 times yt minus 7 equals to u. This is example of seasonal autoregressive model of this is non-seasonal order, so that describes the number of flags here. This is seasonal, so this is non-seasonal AR order, this is seasonal AR order that describes, so this one describes how many legs we have in this polynomial. This number 1 describes how many legs do we have there in seasonal part. For example, if I consider seasonal AR model of order 1, 2, frequency 12, it looks something like 1 minus 0.6 L times 1 minus 0.3 L 12 plus 0.1 times L 24 times yt minus 7 equals to it's okay. Just a moment, I will check. Let it be a little bit smaller. Just a moment to make it. It's ut, and here I will write plus 0, 0, 2. Like this. Okay, this is example of seasonal autoregressive model. So what do these numbers mean? The first is the number of flags in the first, number of coefficient estimated in the first bracket. Second, here I have 2 coefficient that needs to be estimated in practice. Okay? Yeah? Tough? That's tough? That's hard? Okay? Now let's just check some properties of this model. So let's check some properties of this model. So my exercise is and 3 assumptions are so we have 3 more assumptions. So because I'm a little bit too fast, because I always need to tell 3 assumptions, additional assumptions about u, assumptions about link between y and u, and assumptions about stationarity of u. So 3 assumptions are hidden. I have not mentioned them. That's bad style. Let's be explicit. We have 3 more assumptions. Assumption number 2. So the first is equation. The second assumption is that yt independent, and usually they are seen normally distributed, but you may change this assumption. You may introduce, I don't know, t distribution, or like in Garch models you can have fat tails. You need to also introduce the assumption of y1, yt, and the future noises independent. And we need to introduce assumption that yt is stationary. So let's make these assumptions explicit, because I have written equation, but I have not stated other assumptions. We need to state them to complete the specified process, because otherwise I can pick up any y0 and start the sequence given some initial conditions, and we need to say that some sequences are not possible. Okay? So these 3 assumptions, we have already used them, but we need to state them always. Yeah, let's continue. Okay. So let's solve an exercise. Let's consider this process. And my exercise, so we have equation and 3 more assumptions. So my questions are, first question. I think that will be rather easy to calculate correlation. That's tough to calculate correlation, yeah? Can we calculate correlation? No? Because correlation will be rather tough. I'm thinking a little bit, is it easy? So it's obviously easy to calculate expected value of yt. It's easy to calculate variance. Or no, variance is also tough to calculate. Expected value.
You try to calculate at least.
Okay, let's discuss how to calculate. Okay, let's discuss how can we calculate. How can we? Because 12 is realistic for monthly data, but I think we will need 12 equations. So let's discuss how can we calculate. How can we calculate variance of yt? I will not write all 12 equations, but let's discuss how to obtain 2 equations, and then if you understand the logic, you can write all 12 equations. But maybe it's too long. It's realistic, but it's too long. Okay, second point is given y1, y2, y3, yt. So you have this y. Imagine that we have more than 12 observations, because otherwise it's non-reasonable to estimate seasonal model. You have more than 12 observations. And my question is, what is the distribution of yt plus 1, given that you know? So what is the distribution of the next y, given your information? What is the distribution of y 2 steps ahead? So you know yt minus 1 up to y1. What is the distribution of yt plus 1? What is the distribution of yt plus 2? For example, exercise 4, point 3, let's imagine that you have sigma squared u is 16. Let's imagine that y 100 is 6, y. So I will write you 12 past observations. 12 past observations are 8, 6, 10, 7, 5, 12, 7, I need 5 more observations. So this is the last observations, 9, 5, 11, 10. So these are past observations, maybe even some observations before. And my goal is to write 95 predictive interval for yt plus 1. So make interval forecast. This is yt, this is yt minus 1, and so on. These are past values of the process. So my question is about some theoretical properties. What is the expected value of yt? How to calculate variance in principle. We will not do it because it's a little bit tough in this case. My question, what is the conditional distribution of future y given your information? And use the second question to actually make 95% forecast. Because basically that's what model is used for, to make forecasts. Okay? Yeah? Can we start solving it? The problem is clear. Okay, the question is clear. Yeah? start. Pum pum pum. What is, so first let's write without lag. Let's write without lag. First my question, what is lag times yt is
YT minus 1.
yeah, yt minus 1. And what is lag times 7?
7.
T minus 7.
7.
7, T minus 7. Or minus 1.
Oh, 12 in this case.
No, 6. No?
No, 6.
7, 8.
It depends me
It
about
depends on Y.
No, 7 is a
Never.
constant.
yeah.
7, 8.
7.
Huh?
Equals 7.
Oh, L7 doesn't matter. Yes. Ну, это же константа.
Yeah, it's a
Типа,
constant and what is L times 7?
L7.
No,
J7.
no. I remember, you remember a story about вчера раки были
And what is it?
по 3, но маленькие.
What is the SAR?
Seasonal auto regression or seasonal auto regressive model.
Ну, ты выбрал момент.
Нет, это как бы... это-
А, it's 8.
Извините,
Yes?
пожалуйста, как бы, но никто не знает, что это.
Okay, so it's 7.
I
Yesterday
told twice
7.
that's 7.
Sorry?
I told twice that it's 7. I told twice that
Yeah,
it's
yeah,
7.
yeah. You're right, but you
Не
were
было, не звучало
not
удачно.
the only one to.
Самое слабое звено.
Okay, yeah. Past value of 7 was 7. Okay, so now we can multiply. 1 by, so when you multiply, well, I will open first, I will multiply these two brackets and I will multiply by. Okay, I will have 1 minus 0.7L plus 0.35L to the power 13 minus 0.5L to the power 12 times yt minus 7 equals to ut. Okay, so I have opened first two brackets. Now I multiply by this bracket, and rules are very simple. When you multiply something what is changing by log, you obtain previous value. When you multiply something that is constant by log, you obtain the constant itself. Okay? Yeah? So I will have yt minus 0.7, yt minus 1 plus 0.35, yt minus 13 minus 0.5, yt minus 12, minus 7 plus 0.7 times 7, minus 0.35 times 7, plus 0.5 times 7 equals to ut. So this is equation without lag. Okay?
Would you explain how we get this equation in the second line on the center block?
It's given in the exercise, so I give you the equation. Normally, how it's obtained in practice, the model estimated by maximum likelihood. So I gave you the equation. So the equation is like this. In practice, we have parameters there. Instead of 0, 7, 0, 5, and 7, we have alpha, I don't know, beta, yt minus mu equals to yt. And these parameters, alpha, beta, and mu, are estimated by maximum likelihood. So in real, when you estimate model on the computer, you say, I would like to have seasonal auto regression of first non-seasonal and first seasonal order with frequency 12. So computer understands that you means that one parameter non-seasonal, one parameter L12, expected value, and so
Okay, and this minus behind 1 and 1, it isn't minus. It is a form of
notation.
form of notation.
Yeah. Yeah.
Okay.
So it's like more or less m dash. dash. Okay, it's not a minus, it's a dash. Okay, so this is the equation of my process. Yeah. I can take. I can calculate expected value. So let's calculate expected value. I may calculate expected value for this equation, or I may directly calculate expected value here. Okay, because it's more or less easy that lag of expected value of yt is expected value of lag of yt. Okay, yeah, because it's previous expected value. It's expected value of previous value. So it's the same thing. So I may roughly take expected value. Yeah. Okay. And once again, if I multiply okay. So I can take expected value there, or I can take expected value here. If I take expected value, I see that 1 minus 0.7 L minus 1 minus 0.5 L power 12, expected value of yt minus 7 equals to 0, because the expected value of ut is 0. Yeah. Okay. And we know that our process is stationary. It's assumption. It's our forced assumption. We stated that our process is stationary. Okay. If the process is stationary, then expected value of yt is expected value of yt minus 1. Okay? So if the process is stationary, lag does not influence expected value. So for stationary process, that should just be expected value of yt. So for non-stationary process, lag of expected value is not the same thing as expected value itself, because it's past value. But if the process is stationary, and that is a requirement for stationary process, one of the requirements, then lag does not influence. Okay? And for stationary process, if you multiply by L, it's just like you multiply by 1. Okay? For stationary process, when you multiply expected value. So I may just remove L here, because this is constant. That is, this value does not change when you multiply it by lag. Okay? So you can just replace lag by 1 when you multiply it. Okay, so I have an equation like this. 1 minus 0.7 times 1 minus 0.5 times expected value of yt minus 7 equals to 0. I cancel that term, and I see that expected value of yt is 7. That's basically very easy. So this number is expected value of y. What's the problem? Magic, yeah.
Yes.
Yeah, magic. A rabbit.
Why we decided that L is a 1?
We decided that our process is stationary.
I
So
understand it, yes.
L times expected value is so our process is stationary. So what does it mean? That L times expected value of yt is just expected value of yt. Okay?
It's
The requirement of stationary
I
process.
know,
It's not true for any process.
It's the unique solution for this equation, that L is 1. Yes?
No. I'm not solving for L. I'm solving for expected value of yt. The first assumption, this assumption says me that the expected value of yt.
This part I understand.
Okay, so if you understand that lag multiplied, so by this assumption number 4, I have this equality. Okay. So when I multiply L by expected value of yt, in general, it will be expected value of past yt, in general. But for this particular process, it's the same. Yeah, it's constant because it's station. In general, it's not true. It's only the conclusion consequence of the assumption number 4.
Okay.
So when I multiply by L, it's the same thing as I multiply by 1 for this particular process. So I may replace every multiplication by L, if I multiply expected value, I may just replace by multiplication by 1. 1 acts on expected value of yt exactly as L. So this equation says that when I multiply my expected value, I can multiply by 1. That the consequence of stationarity, one of the consequences.
Yes, and the solution that for this particular case that L is equal to 1.
No, L is not equal to 1.
Just
L
show
is a,
this L multiplied by 7 is equal to 7. It's the same case, right?
yeah.
So, он имеет в виду, что мы решили...
L is not...
Что L это не переменная.
L is
Это
not a
оператор.
variable.
Это оператор.
Yeah.
это
L,
Это просто
yeah,
оператор.
L is operator, is an
Оператор
action.
ладно.
I'm
Okay.
saying leg operator, yeah.
Okay.
Leg is not a constant. No, it's written like multiplication. Yeah, it's just a notation. Leg is not a number. Yeah, yeah, that's a great idea. L is not a number. L is operator, maybe, but like in linear algebra, when you multiply matrices, you write multiplication. Yeah, you write A times V, but it's not simple multiplication. It's like you have special rules for matrix multiplication. So L is it's written like multiply. Yeah, but that's
Unexpected for me here.
yeah, but the true meaning, if you're speaking about rigorous mathematics, then L sends sequences to sequences. So you have a sequence and it transforms sequence into sequence.
Okay.
So L of sequence 5, 6, so you should have infinite sequence. So it shifts index by 1. So L is applied to sequences.
And also, I have a question. In a more general case, L multiplied by the expected value of yt is equal to expected value of yt minus 1
Yeah.
in the most general.
Yeah.
But in our particular case,
Yeah.
L multiplied by expected value is equal to the same expected
Yeah,
value because of the stationarity.
Yeah,
Right.
exactly. Okay, so we have found the expected value of yt. You may also write without legs, calculate expected value, and find that the only solution is 7. So, but without legs, it's a little bit more lengthy. Okay, so let's find conditional distribution. Because okay, let's look. Okay, no, yeah, we can do it. It's long, but we can do it. First, let's simplify.
Try break maybe.
Sorry?
Break.
Break? Okay, let's have a break.
That doesn't matter.